Stargazing with me, Hannah. I'm gonna wait for the notification squad to pop up here, so I'll wait about 3 minutes until to start up the action. Oh, I accidentally dropped my phone here. Okay. Danielle, I think you have to mute yourself. I can hear myself when I talk. Great. Okay, so yeah, so I'm just gonna wait just like a few minutes, maybe like 2 or 3 minutes for the notification squad to start joining. But in the meantime, I am here at the Dyer Telescope all by myself. My co-host Jacob could not make it tonight, which is all right. But I'm going to be showing you guys some cool things, just like we do in interactive stargazing. But there is some things that we have to be aware of tonight. So there is a little bit of clouds. That's the whole reason why the interactive stargazing earlier was canceled, was because it's pretty cloudy in Flagstaff. JB asked, yo, hosting solo tonight. Yes, I am. Fingers crossed. We'll see. No, I'm actually really excited to be doing this by myself. So I think it's going to be so much fun. But yeah, so the weather is a little not working with us in Flagstaff. It's cloudy. It snowed last night. You know, it was so funny because I was looking at the weather like all week because I've been looking forward to sunny, warm days. I'm from Phoenix, Arizona, so I'm really used to the 100-degree weather and like the warm weather. So I was like, oh, I really hope it starts warming up here and starts getting sunny. And then I look at the weather and I'm like, oh my God, it's going to be sunny. I'm so excited. And then like the day would come and it would be cloudy and I'm like, okay, it's not sunny. And then it starts snowing and I'm like, all right, it's definitely not sunny. Hi everyone. Hi Percival Lowell's ghost. Oh my gosh. Hi. Hi Abcab. What's up? We need the snow. Oh my God, I'm so done with the snow. And so I don't know if you guys have heard the news, but the Methane Marathon has also been pushed back. So it's supposed to happen like this past weekend, but again, it was snowing, so we couldn't do that. So now we're planning to do it this weekend, this Saturday. I don't know what day that is. Let me double check what day Saturday is. I have so many things to do. It is the 20th. So March 20th at 6:45 p.m. is when we are hoping to do the Methane Marathon. But again, we'll see. Techie Matt, hi, Techie Matt. Yes, Dr. Danielle. Yeah, March 20th through 21st is when we're going to do it. Sorry if I'm like looking down. This is where my chat is. It's like down here. So I can like prop it up here. I need a phone stand. So now that there is some people here, yeah, let's start opening up the dome. So it's kind of windy outside too. So we're just gonna do it and we're gonna see what happens. And plus I'm like really excited to show you guys how like we open up the telescope and how it works. It's really cool. I feel like a mad scientist whenever I'm in here, especially with the red lights. It really gets the mad scientist vibe going. So I'm gonna aim my thing up here. Okay, so I'm gonna point out some things before I actually open up the telescope because I want you guys to know what I'm talking about when I say these things. So let's aim this. Okay, perfect. So here, I can get up. I have AirPods in. I don't have to be near the thing. So you can't even see me. Here is my telescope, and this is our plane wave CDK telescope. I had to put my glasses on so I can see myself. So this is the actual telescope. These are like the trellises underneath here, and this is like a skirt that we have on the telescope to protect it because the primary mirror is inside here, and then at the very end is where a secondary mirror is. And so when we have this skirt, because it's an open trellis telescope, lights can't like get inside, so it like protects it. So that's why we have that little skirt there. And then this is our mount of the telescope, so it moves side to side like I can move it. Oh my God, I don't know if I'm allowed to do that, but I'm doing it. I won't do it anymore though. This is our mount, and that's how our telescope moves. So I forget, this is an equatorial mount, I think. Oh my gosh. And so the telescope can move like up up and down like this and side to side. And that's how we point to our different objects. And then this thing right above me, can you see me in the corner? Right up here, I'll point it out. That thing, that is the slit of the dome of the telescope. It's an alt-azimuth. That is the kind of mount that our plane wave CDK is on. But so, again, this is the slit of the dome, and so we have to open that up so we can look outside, and then the whole entire dome like rotates. So I'll show you here. AbCab says fancy. Thank you. So yeah, and then we have our dome light. I think there really isn't much to point. Oh yeah, there is one more thing to point out, which is how we move the dome. So there is a telescope in the way of it. So that's so funny. We have an extra telescope in here because there was a Jupiter and Saturn conjunction in like December, and we had this extra telescope to look at Jupiter and Saturn. But right behind it here, you can barely see it. There's like some glowing little boxes, and those are buttons that say left, right, open, close, and that's how it goes. So there's also one other thing, safety first. I mean, I know how to open up this telescope. I've done it a billion times, but just so I can show that I'm a responsible educator, we have procedures on how to open the telescope written down, just in case you forget, it's a bad day, you know, I don't know what's going on, you had a big exam you got to study for, and you just don't know how to open up the telescope, that's fine. We got this here. So the first thing it says for me to do is to make sure that the power is running in here. I'm pretty sure it is because the lights are on. So let's just double check. Yep, the power is on. Look at that. There's some switches over there to put the power on. Okay, and now I can open up the telescope, or the dome. So I'm not going to point it at me. I'm going to be pressing these buttons to open it up, but I don't think you need to look at me. So I'll have it here on the dome. Here, let me move some stuff around. Okay, oh my God, look at that view. Oh, I'm so excited. Sorry if that was loud. Okay, ready? So I'm gonna open the top shutter of the telescope, or the dome first. Okay, so ready? Here you go. Can you see it? Yeah, you can. Look at that. And it's kind of a slow procedure, so it's gonna take like a minute for it to open up, but it's still faster than some domes. I mean, it's a case-by-case scenario. Some domes are like really slow to open up. Some are like insanely quick. Some are automated. NAU's campus has a telescope dome called the BLT, the bacon, lettuce, tomato. No, it's that was so cringy. It's a Very Let's Telescope. That's what the BLT stands for. And that dome, you have to manually open it, like crank it with your hands. It is so bad. And the Clark telescope on campus here, how we open those domes up. I mean, it's ancient, built 1896. I mean, we've fixed the dome since then, but we still have to open that manually. There's like ropes and everything that we have to like pull. That's the majority of how I get my upper body workouts in the summer, is opening the Clark telescope shutters, which is a lot of fun. So this is about to be done opening here. You can't see it moving anymore, but there's just like a little bit more. And so now we're gonna do the bottom shutter. So trust me, there's still more to do. Here we go. Look at that, so much fun. And this is gonna take another minute for it to lower, but it's super cool. I don't know, it's like, it gets me so excited, like when I'm coming into work and, you know, getting the telescope already and I have to open up the shutters. It's like the anticipation is building, because I have to wait for them to open up. It takes such a long time, but it's okay. That's all right. And then as soon as they're open, we're game. We're ready to open the telescope up or turn it on, because we don't have to open it up. Let's see. Almost there. It looks like it's open, but it actually isn't. There's just a second. Okay. Super cool. Let's see what the chat has to say about that process. The diary is so pretty. Thank you, Techie Matt. Oh, that's so sweet. And so I opened up the telescope dome, so now we get to turn the telescope on. But real quick, I forgot to point this out. There's these, dang telescope's always in the way. There's these doors to the diary telescope that have like little portholes. They're like these circular windows, and it just makes me feel like I'm in a spaceship. So again, when I'm like opening up the dome, like powering on the telescope, it makes me feel like I'm on the Death Star, like powering it up, ready to explode the objects that I look at. That's how I feel. So, spaceship. I'm in a spaceship. Okay. So I'm going to point it at the telescope now because it's going to move around when I turn it on. So the first thing I have to do is power the telescope. So I'm not going to show you that because it's boring. I just have to press the on button. On. Okay. And now I have to power my telescope on. So it's on the other side. On the other side of the mount, there's a power button, and I just click it. And now it's on. I have to move this telescope out of the way again. Oh my gosh. She's heavy. Okay. Our telescope is powered on. And now I get to power on the controls for the telescope. Can you see me? Here, I'll move back into view. I'm all over the place right now. That's what's so fun, is that I get to walk around all the time and I get my steps in for the day. So I'll sit down for this part again. Okay. The telescope's not going to move while I do this. I'll move the camera back up when the telescope will move. So I have an iPad that I can't open up. They put like this protective case on it, but when my fingers get so cold being here, I like can't open it. There we go. All right. So I have my iPad. Here it is. Shout out Apple. Okay. So I have to go to the remote home to turn this on. And by the way, I'm so sorry for those of you who are just joining and didn't see my intro in the beginning. My name's Hannah. I'm an educator here at Lowell. I'm also a researcher here. I do research. Okay, sorry, this is taking a second. This is our remote home. So I don't know why it's taking so long, actually. That's okay. But let's see. Is it freezing cold outside? Yeah. Oh my gosh. It is like 20 something degrees in Flagstaff, and here I am outside. I'm outside. It looks like I'm indoors, but okay. So the thing with telescopes is that you want the indoors of the telescope to be the same temperature as the outdoors, because if it's hotter in here, if there's like heat in here, heat rises like a wave, you know, it's like doo-doo-doo-doo, and heat will rise in front of the telescope and make the image blurry. So it's cold in here. It is not warm. There's no heater in here. Okay, my remote home. Oh, it works. Okay, so I just had to exit out. Okay, so I just go into my remote home, my remote computer. Oh, I have to type in the password and username. Do not look. Secret, secret. Okay. Sorry, I have to concentrate so I don't spell anything wrong. Okay, so it's connecting to my remote home. I know you really can't see this too well, but it's the thought that counts. So I'm in my remote home, and then I open up my software for the plane wave. So like plane waves have like their own software called plane wave interface. Super technical. No, it's not. And then I just connect to my telescope. So this one I'll try to show you. And then I have to move it up so you can see it move. But there's a button that says connect. Oh my God, and that's it. So I have to connect it, and then I have to enable the Alt as mount, and then I home it. Okay, pay attention. I know, here, I'll get out of the way. Ready? Oh my God, look at her go. Look, where's she going? Where's she going? What's she doing? She's trying to find home. So basically what I just did basically what I just did was there's a command for the telescope to, it's called home mount. Oh, this looks so funny, it's just my glasses. And what I'm doing is telling the telescope to find home. So it's been programmed to have this as its home position, and that is so the telescope can just kind of figure out like where it is, like, and the different coordinates that we use are like the right ascension and declination to find things in the sky, so it like can center itself and be like, all right, so this is where this object's going to be. This is basically where I am. So it found its home. It's happy, and now we can start pointing to things. But if I want to start pointing to things, I have to plug in my camera, and that's the whole reason why we can see the things. Oh, my computer says battery running low. Did I forget to plug it in? Oh, it unplugged when I moved it. Un momento, please. Okay. There we go. I plugged it in. Okay. What was I talking about? Camera. So now I have to plug in the camera. So we use a Malin cam. I will show it to you here. I just kind of have things all over the place. My workspace is really tiny in here because we want all this space for the telescope and for guests. So we try to maximize the space in here. Okay, so here is the camera that we use. It is our Malin cam. Can you guys put the specs in the chat? I think Danielle or JB knows the specs of the Malin cam. I forget what it is. But this was donated to us by Malin cam. So that was very, very nice of them, and I love it. It's so cute. So here it is. Here's our camera. Actually, before I do this, I have to do something else. Sorry. Okay, no specs yet. All right, so I'm going to get the like connectors plugged in real quick. So I'm going to be off screen here just for a second while I go grab them. But there you go. So I have this like weighted connector. I don't know what to call it. It has a specific name, eyepiece holder, and it's weighted because the telescope right now has an eyepiece in it right here. Can you see it? This is the eyepiece. It's a 30-inch. And the eyepiece itself is heavy, and so the telescope is like precisely balanced. So when we look at objects, it points correctly. JB, I can't see what you sent. It just says 3 stars. And 2 dots. I don't know. Oh my gosh, I forgot to shout out the people who followed us. Thank you to Flavor Davy, Claire Sue Who, Percival Lowell Ghost, and Seattle My Waifu. Heck yeah. Thank you guys so much for the follows. JB, thank you so much. It's a Malin cam Sky Raider DS 2.3 Plus. Oh my gosh, NASA used this? I didn't even know this. It was used by NASA during the 2017 eclipse that was live. That's so cool. So that is the Malin cam that we have. But let me put this connector in real quick. I was talking about how the eyepiece is heavy and it's balanced precisely for having eyepieces in it. But because we're going to put a camera in it, the camera actually like isn't that heavy at all. It's really light. So we have to put a weighted connector in it so we can be pointing nicely. So I have to take the eyepiece out, and I actually have to take the diagonal out. And so for those of you who don't know what a diagonal is, I'll bring it up here. Here is our diagonal. And it has like a little mirror in it, and it like bounces the light to the eyepiece from the telescope to the eyepiece, just like that, just a diagonal. So I take that out, and then I get my weighted eyepiece, and then I put it in here. And this is what we have to do every time. And this is what we do. We don't take the diagonal out when we switch like eyepieces for like different magnifications and stuff, but it's a whole like hands-on process. So there we go. And now I can put in the camera. So we have a request from YouTube actually for an object, which is M42 from Joe Wolf. So by the way, for the Twitch viewers right now, we're streaming to YouTube and Twitch right now, which I think is super, super fun. So shout out to YouTube and Twitch. Randy Attacks says, do hickey wait connector for camera thing works. Thank you for the follow, by the way, Randy Attacks. So while I was just reading the chat, I just put in this focal reducer. Focal reducer? Is that what it is? Basically, this camera has a very, very small field of view. So when I put this in, it makes it just like a little bit bigger. I know it sounds backwards, but it makes our field of view just a little bit bigger. So I'm gonna put this in the telescope right here. There we go. Camera is in. And now the last thing I have to do is plug the camera in to the computer. And this is really not technical at all. It's just like a long cable, but it's all kind of tangled. So let me untangle it here. And then I just plug one in. Okay, give me 1 second because I'm blind. My vision is so bad, so I have to get so close to things, even when I have my glasses on. Okay, it should be connected. And then we can test it out by pointing to something here. The one fun thing about having a camera with a long cable plugged into it is that it drags on the floor. So I have to be careful to not trip when I'm in here playing around. Okay, so now I can share my screen and we can see if it's working. So let me put everything away, all nice and pretty. And let's do this. So I am sharing my screen now, and I just got like the light just got really darker, but that's okay. All right. So can you guys see the screen? Should be able to, but we have to change scenes here. Click. Let's see. Okay. So while we wait for that, I'll load it up here, turning it on. Looking at the dome. That is so much fun. So I'm not the one running OBS right now. We see the screen from Mally, all good. Yeah, so if there's ever a delay with like the scenes switching, it's because I'm not running it because I have too much to do here with the telescope. So, okay, we can move the telescope now. So I did not show you what I just did, but I opened up my app, Sky Safari. Shout out Sky Safari. Sky Safari has this app on the App Store. I'm not told to advertise it, by the way, but I really love Sky Safari, so I like want to tell you guys how awesome Sky Safari is. It sounds like an ad, but it's not. You have to pay for it. It's like $2, but like in my opinion, as a astronomer, I think it's like one of the best sky apps out there. But you do have to pay for it. I haven't tried a lot of the free ones, but like they wrote the code for Sky Safari to make it work for our telescope. So all we have to do is connect our telescope, and this app is so crazy. We just like point and click, and it goes to it. Before we had like the plane waves, so Lowell got the GODO, the Lowell Open Deck Observatory plane wave, like October 2019, I'm pretty sure. And then we got this one like just a few months ago. So it's very new, this system to us, and it's been a lot of fun because before we had the plane waves, we had to move all the telescopes by hand. So we had like portable telescopes. And we had some like really like complicated systems, but yeah, it was all by hand. So we like memorized where like all these objects were, and we just like moved the telescope really quick. And a lot of the telescopes like weren't tracking. The smaller ones we used at least, like the big ones like the Clark and stuff tracked. And the other telescope that was in here before, I forget what it was called. It was like such a long time ago, even though it was literally just in a few months ago. Let's see. Hi, Jacob. Thanks for joining. Let's move the telescope. So all I gotta do is connect it. Let's go. Connect the telescope, and it shows you where we are looking in the sky. So let's see. So someone requested, so I'm gonna focus it on a star really quick before we get to suggestions, just so I can make sure it's like all nice and pretty, and I'll show you how I do that. So I don't want to move the dome. I guess I can. So let's look kind of to the what's a bright star? Arcturus is rising. Let's do Regulus in Leo the lion here. So we're gonna go to, just because, like I was saying earlier, in Flagstaff it's like super cloudy right now, and it's really patchy, and like the weather just like does not want us to do viewing. So we're gonna try. But the last time I looked outside, the sky right above downtown Flagstaff was like perfectly clear. So let's hope that it still is. So I just moved. Oh my gosh, I did not show the telescope moving, but it just moved just a little tiny bit to Regulus. But what you're seeing is the dome, because the telescope's still pointing at the dome. So I have to move the dome. So I'm going to go move it now. I'm going to move out of the view for a second here. There's so many cables, I have to make sure I don't trip. Okay, and so I just pressed a button that says go to the right, and then my telescope moves. Oh my gosh, the dome sounds so creaky right now, and it's just because it's so cold and there's like ice and it's like breaking. No, the dome isn't breaking. That's not what I mean. I mean like the ice is breaking from the tracks. Okay, and so something I do, I don't know if you can see me, but I like get behind the telescope to line up the telescope in the dome to make sure it's all aligned. And I barely overshot it. Sometimes I have to fix it just a few times to make sure it's in the right spot. And yeah, we might be able to see it. Let's see. What's that? Oh, look at that. Okay. So something else that we have to do with our telescope is we get to play video games on it. So this is a game controller, and I can move the telescope with it. Oh no, don't tell me the batteries are. Let me see. Not turning on. It might just be really cold. Again, it's been like super cold. Oh, it turned on. Yeah, it was just really cold. I had to warm it up for a second. Let me connect my controller here. 1 second. Okay, let's see if it's working. Oh, not yet. Warm up. It's a little cold. Cold time. Is it working yet? No? Okay. I have to do some troubleshooting really quick. Yeah, it's all my iPad. I can't tell if it's because it's cold or if it's just like not working. No, it's not working. So strange. It is not working. Let me think here real quick. What do I do when it doesn't work? Shut it off? Shut it off and turn it back on, I guess. That always works. I can't even take this bottom part off. It's so cold. It's like frozen shut. Oh, there you go. I opened it. I'm going to take the battery out real quick. Oh my God. I don't know if you just saw that, but I totally just saw my breath. It's not that bad though. Like I'm complaining that it's cold, but like it really isn't that bad. Is it working still? No, come on, man. Let's go. It just does not want to work. Yeah, I just think it's really cold. Rescan. Come on. Oh, I think I know what it might be. There's a little dongle that might need to be played with here. I don't even see it. What's going on? It's someone take it out? Oh my God, what's happening? Okay, I don't know if this is going to work, the thing, so I'm gonna see if I can do it by hand with my iPad. So on my iPad, I have like controls too, so let's see if I can move it like that. Oh my God, I can. Oh, that was like way too much. Let's go back, but slower this time. I got too excited. I moved it way too fast. Okay, let's turn this down. Let's turn this down. Okay, ready? Now let's see if I can move it, but slower this time. Oh, where'd it go? Did you see it? Where'd it go? Okay, I'm moving it back. That's what I liked about the controller, the game controller though, is that it moves so slow and I don't have to worry about it. Oh, did a cloud go in front of it maybe? Maybe a cloud went in front of it. Let me turn the exposure up. Oh, that's definitely a cloud. So we're gonna go to another star. It's another really bright star. We'll try Castor. Oh yeah, there's like a big cloud in the way. Let me answer this question real quick. Bruce asks, are you an astronomer or a cosmologist? I would call myself a planetary scientist or an astronomer. I don't study the cosmos. That's like galaxies and stuff. Oh, it's back. I don't have to actually move it. Yeah, I'm really into planetary science. I'm into like planets and like rocky bodies, so like asteroids and moons and planets. So yeah, okay, let's move this. Why does it move like way too much? What the heck is going on? Nope, that's not what I want. Huh. I don't know. My system is acting up right now. Jog. Let's try this. No, I don't want to do that. So yeah, a lot of the research that I do at NAU is on Mars, and then the research that I do here at Lowell is on near Earth objects or asteroids, NEOs. And I also do other research at Lowell. I do stellar research. So the people that I work with, the astronomers here, oh my gosh, more people followed. I'm so sorry. I'm like not looking at the thing. Thank you so much, RW Grimm and Bobo135RT. Thank you so much for the follow. I'm like trying to troubleshoot this, and I wish it was working. So I work with Dr. Lisa Prado and Dr. Nick Moskovitz. So Lisa Prado does stellar astronomy, and Nick does NEO research. And I really like it. I like it so much. So I'm really into like spectroscopy. So I think that's like my thing that I really like. So I got my degree just this past year, so May 2020, in astronomy, and a minor in physics. And yeah, I really liked planetary science, but I didn't know what I liked about it. I couldn't tell if I liked you know, just Mars, or like if I liked the geology part of it, or like what I liked. Sorry, but I think it's spectroscopy. I think I like spectroscopy the most. It's so cool. It's a lot of coding. It's really intensive. So that's what I really like about that. So I'm going to try, I don't know, the telescope just really does not want to work right now on this day. See that? I like try to move it and it just like doesn't move to the place that I tell it to go. And my joystick isn't working. I'm going to try to, oh my God, I got it in the field of view. Oh, okay, we're going to take this lucky situation while we can and just keep it here. Okay. Hi, Ohana Disney girl. Aloha. Welcome. So, for those of you who are just joining, I was like troubleshooting the telescope here for a hot minute because everything's working fine, but it's like not moving to the right place that I want it to move. So it's like being really touchy, but that's okay. We can figure these things out. And so now I'm going to focus the telescope. So we're looking at Regulus right now, and Regulus does not look like that. I'm going to focus it while I talk. But so what you're actually seeing is like the internal structure of the telescope. And so that's like the primary mirror. And so if I focus it down here, I'm going to lower the exposure just a second. And all I'm doing is like moving the focus knob. Okay. So I'm just trying to get it into a tiny little pinpoint there. It's looking really good. Oh, perfect. Look at that. Okay, and the clouds are moving too. So this part of the sky looks really good in Leo, so we're gonna stay in Leo. I loved seeing me and my family's favorite place in Flagstaff here in Twitch, says Ohana Disney Girl. Oh my God, that is the sweetest thing. Oh, you're so sweet. Well, I'm glad that, you know, you're enjoying this and that we can do this for you, you know, and show you all the cool stuff, you know, even if you can't make it here to Flagstaff, we still have all these live stream events that we do to show you guys these different objects. And that's why I love working here too. It's just like being able to show people like these cool things that don't have access to it. Yeah, so let's see. Zach Davis asked, can we see a galaxy? So yeah, we'll try to see a galaxy in Leo. So yeah, we're gonna try to stay here just for now, just because I looked outside and again, it's partly cloudy, except for Leo. So let's hope the clouds don't move too fast here. It is a little windy. So let's open up my iPad back here and we'll go to one of the Leo triplets. Those are my favorite. So if you guys were in the stream last time, we looked up some of the Leo triplets, and one of them is named the Hamburger Galaxy. That's my favorite. Here, let's see, is it like M66 or like M65? I can't remember. This one. Let's go. All right, so I'm gonna move the telescope. So I'm gonna move my big head out of the way. It's not gonna move that much. You can barely see the slit there. Okay, here we go. We're gonna move it. So it barely moved, just a little bit. That's all right. That's what we want. And then I have to move the dome just a little bit. Again, I'll move this camera. You can't really see the dome. You won't see it move. You can watch me move the dome. Okay, here we go. We're gonna move the telescope dome. Can you see me? Here we go. I just press a button, that's it. And then I stand behind the telescope and I make sure it's aligned. I have to move it just a little bit. And we're good. There's a little tiny cloud coming that direction. So let's see what we can do. Let's see what we can do. I can see my breath. That is so crazy. Which building are you in? I'm in the Dyer Dome. So this, what was this called before? My brain. So it's called the Dyer telescope now because we have a new telescope in here. I can't remember what it's called before. The McAllister! The McAllister! Thank you, Danielle. It was called the McAllister telescope. Oh my gosh. And so we have the McAllister telescope in here, and it's at the very edge of campus. It's like if you're going to the Clark telescope and you like pass by the Clark, it's right at the end of that walkway. So yeah, that is what building I am in. It's often next to like the fire hydrant. What's going on? My system. It's so funny. It's like trying its hardest to not work with me. Come on, man. My live second. What the heck? That looks okay. So that's not what we're trying to get, but that picture looks kind of cool. That's so funny. Yeah, that's like totally not what we're aiming for, but it still looks kind of crazy, but you can see the galaxy that we're trying to get right here in the corner, M66. So I'm going to try to center it again. But like, why does it look so funny right now? Oh, I see a star right there. So like, why did I mess with this? Oh, what did I do? So we had the settings cropped out just because they're like kind of ugly and they don't mean anything. But okay, I have some settings on the side here to like adjust the color of the image that we have. So now that I have that done there, I can move the telescope. Okay, so I'm gonna explain what I just did. So, Ohana Disney Girl says, I just realized you're live on YouTube and I might join in the chat on the YouTube live stream. Yeah, that's totally fine. I do have only the Twitch chat pulled up though, so I might not get to your comment on YouTube right away. And then Rainy Tack says, I think it's the one at the top. Yeah. And so what I'm doing is I lower the exposure for this picture so I can just see a bright star so I can center in the galaxy, because the only reason why we could see the galaxy in that last picture is because I took a long exposure. So, but I want it to be centered. It was like kind of off in the side there. So I shorten the exposure, I move the telescope, and then I make it a long exposure again just so I can see everything. So let's try to move it again. Oh, wrong. Is that the right way? I have no idea what just happened. So let's see. We're just gonna see it. We're gonna take a picture and see what it looks like. So I'm gonna take it for like 12 seconds. The last picture I took was 22 seconds. That was kind of overkill. We did not need to do that. And then we got a lot of color from the dome lights itself. So we'll see what we can get here once it loads. Taking a second to think here. It's already been 12 seconds. Yeah, sometimes it's like, do I want to show you the picture? Oh, okay. Now it's on the complete opposite side that I want it to be. So this red color that we're seeing, so the picture's supposed to be black and white, basically. But because I'm in this lighted area, so you guys can see me, the telescope is actually like getting some of the dome light, which is fine. But that's what we're seeing here. And do you see how it keeps getting like brighter and it's like yellow right here? That's a cloud. That's a cloud moving in front of the camera. Ah, these clouds, can't they just leave? Okay, so I'm going to try to move a telescope again. Let's see if I can get that star. This star, I want this star right here in the center. Ah, I wish my joystick was working. My gaming controller, but no, it does not want to work. There's like, I don't know. Okay, let's see. Let's see. So I have to do these really quick taps. Tap. Did it move? Oh, it's back all the way over there. I want it to move slower though. It's like jumping around so fast. Oh no. I am trying for M66. That is the galaxy that I'm trying for. And the telescope, my joystick controller for my telescope isn't working right now. I'm gonna plug it in and plug it. I can't tell which is the thing though for it. I'm unplugging something and I hope it's the USB thing for my controller. I actually have no idea what I just plugged in though. I'm again hoping it's the right thing. Okay, all right, I just plugged something in and let's see if I can get my joystick to work. If not, we're just not gonna have good pointing tonight. And that's all right, I guess. I'll try my best. Okay, let me troubleshoot this again. It says it's detected. It says, I can tell your joystick. No, and it's not working. I'm so, okay. Yeah. So yeah, again, I'm gonna have to move this by hand, but when I move it by hand, it just does not want to move to the right place. Where'd that star go? Yeah, so our pointing is like really bad tonight. And that sucks because my joystick isn't working. I might see if like I can get one of my supervisors here to fix it for me. I'm gonna text them real quick. I think one of my supervisors is here. Kevin. See, there's my galaxy. My galaxy is right here. I'm 66, but it does not want to go in the center. See how it just moves all the way across the screen? I can move my telescope, but just not right in the center. Okay, let's go to another one. Sad. Go to this one. I'm gonna text Kevin too, real quick. Where's my phone? Looking at the chat. Excuse me while I text my supervisor to come up. I'm saying, hi, can you help me at the diner? My joystick isn't working. Let's see. Let's see if he comes up. Sometimes what's so funny is it's so dark like around here. Oh, you can see my galaxy is right here, but it's not wanting to center. But it's, you know, so dark around here, and so when my manager or my supervisor, when he like walks up with his little flashlight, it scares me so bad. Okay, I'm gonna crank this exposure up, see what we can get. Let's see what we can do. I didn't even have to move the dome. I'm like all over the place. You know, I didn't even have to move anything. So super cool. So here is our galaxy in the corner of the picture. Again, it's not like moving right how I want it to, but we're gonna see if we can fix it here. Yeah, so there's part of the Leo triplets. I believe this one is actually the hamburger galaxy. So someone on YouTube asked to see the Leo triplets, and so the Malin cam, the camera that we're using, the field of view is so tiny, so we can only see one galaxy of the triplets at a time. So we have to go to each individual one, and that's what I was trying to do. I was trying to get all of them. So the one that we're looking at right now is NGC 3628. And that is, I believe, the hamburger galaxy. And so the other ones in the Leo triplets are M66 and then M65. And look, there's a cloud passing in front of my picture. Yeah. And they're really beautiful galaxies. And so there's a big cloud. Leo is like the best constellation for galaxies. I love all the galaxies that are in Leo. And someone actually asked to see Vesta, which is in Leo. So that's an asteroid. And we can see Vesta, but again, it's not pointing right. So I don't know how well it's going to look. It's probably going to be in a little tiny corner there, but you know what, whatever. Let's try to see it now. I'm gonna move my telescope. Actually not gonna move that far again. I'll point it up so you can see it move. There we go. That's it. It moved to Vesta. Oh, I don't need this long of an exposure. Here we go. Here we go. Oh, there it is. Oh my God. It's trying so hard. My telescope is trying. Okay, that's Vesta. That's our asteroid Vesta. I actually don't know too much about Vesta. I know it's the largest asteroid. Yeah, it's like I don't know why I put quotes around asteroid, because it is the largest asteroid in the asteroid belt. But there is Ceres, and so at one point Ceres was like considered the largest asteroid in the asteroid belt, but now people are calling it a dwarf planet, which is totally cool. I'm totally down to be calling Ceres a dwarf planet, because then that means it's the closest dwarf planet to us. It's in the asteroid belt. It's just like right over there. So because of that, Vesta now is the largest asteroid in the asteroid belt, which I think is so cool. And you know what I also think is so cool with what I do here at Lowell is that I can look at all these objects, you know, just for fun, but I also can like see them like moving and like being active and like being objects. That doesn't make any sense. So for example, Vesta, you know, well, okay, so for example, when we're looking at like galaxies and stars, they don't really move, you know, I mean, they rise and they set, they like move relative, they like look like they're moving to us, but that's just the Earth's rotation. But like in space-time, they don't move. They're like, I mean, they do, but it takes a really, really, really long time. not in our lifetimes, we're going to see them move. So, but, you know, asteroids and planets and things like that, you know, they're orbiting around our sun. So you can actually, you know, see them move, and you can like see activity, and like you can see, you know, all these different things. And that's also why I really like planetary science. And so I think it's so fun that I can come up here and like look at Vesta, and I can like take a picture of it where it is right now, and then like come back in an hour and take another picture of it, and I can see that it like moves because it's like orbiting, which I love so much. Kevin hasn't texted me back. Oh, yes, he did. He said, on my way. Oh my God, guys, I'm going to have a guest star. I'm going to have a guest star, Kevin, my supervisor. I don't know if he wants to be on camera. I'll ask him when I get a chair, but I'll let him know that we are streaming. I don't know if he knows that he might be on camera. It's going to be so much fun having a club. So someone asked, Kat from YouTube, I think, asked, what's your favorite star? My favorite star. Oh, I answered this actually last time. Vega. My favorite star is Vega. And oh, Kat is Ohana Disney girl. Oh, okay. So my favorite star and my favorite space movie kind of like go hand in hand with one another. And that's because my favorite space movie. Oh, is it Kevin? Hi, Kevin. Just letting you know you're going to be on camera. Okay. Hey guys, here's my guest star, Kevin here. My joystick isn't working. No. And I unplugged it and everything, and it like, yeah. No. All right. All right, guys, we're gonna troubleshoot here with Kevin. So let's hope we can get it working. I'll let you see both. All right, so while Kevin's trying to fix it, we're being socially distanced, by the way. He's not next to me. While Kevin's trying to fix it, so my favorite movie is Contact with Jodie Foster. And in Contact, they, you know, talk to these aliens or beings that live around Vega, and they get these signals from Vega. And so that's like the main reason why I like Vega, and why the movie Contact is such a good movie. But also, I really like Vega just because it has like some cool like things about it. So, you know, it's like the 0 point star, like the foundation star that we use to measure like stellar magnitude. So like Vega is 0. And so anything brighter than Vega is like 1, 2, 3, 4. And then, or wait, backwards, -1, -2. And then anything fainter than that is like 1, 2, 3, 4, 5. So I love Vega. It's such a good one. And then Contact is such a good movie. If you haven't seen Contact, you should definitely watch it. I think that's a movie that actually like got me into astronomy. And so I don't want to like, I don't know if I talked about this last time, so I don't want to like be repeating myself, but in case I didn't, Jodie Foster, I don't mean to spoil the movie, by the way. If you're gonna watch it, shut your ears for a second. But Jodie Foster, you know, she works at the VLA, the Very Large Array in New Mexico, and she is a radio astronomer assistant. So it's like it has her listening to like radio signals, which I think is so funny. But so, you know, they have this large array of like radio telescopes, and they start hearing this weird like repetitive signal, and she's like driving in her car out in the VLA, like repeating the right ascension and declination of the signal, so like other people can track it from like Arecibo and like the VLA and like all these different places. And I was just like, oh my God, like she is so cool, like driving out there like with the telescopes, like right ascension declination. I was like, oh, that is so cool. Oh, it looks like it's moving. Oh, okay. I was like, oh, did you get it to work? Oh, okay. I thought it was working. It's okay. Hopefully we'll get it to work here in a second. But and it's just like, it's such a, I love it. Such a good movie. But you can see in my picture here how like the stars are moving. I like how it looks when the telescope moves, because it looks like shooting stars, or like satellites or something like that. I think it's super cool. Yeah, I don't know what's going on. Yeah, because it was moving with Sky Safari, but not with that. was not wanting to do it. Something's moving. All right, let's go. Okay, so I'm going to help troubleshoot this again really quick. We're going to move to a star. Let's go. We'll go back to Vesta here. Just because Vesta's really bright. It's basically like a star. No, it's not. It's not basically like a star, but it's bright like one. Oh my God! It's working! Thank you so much. I appreciate it. Thank you. Everyone in the chat say thank you so much, Kevin, for saving the day. Yeah, definitely. Bye, Kevin. Oh my gosh, everyone thanks Kevin. Oh my gosh, everyone says, yay! What are we viewing? Oh my gosh, now we can get things rolling. We're looking at the asteroid Vesta AvCab. Kevin rocks. Yeah. So this is Vesta. So that really bright light right there, that is the asteroid Vesta. And so if I were to take a picture of it, like right now, and then we were to come back in an hour and take a picture of it, we could actually see it moving. So actually, I might do that depending on how long I decide to sit here and talk for. So let me get the right ascension and declination. So when I was talking about, contact and that stuff, so that is just like the stellar coordinates or celestial coordinates of the object. So it's like GPS coordinates, but for the sky. So I'm taking a picture of the RA index that Vesta is in now, and then I'm going to take a picture of it. Whoop. There we go. So I'll come back here towards the very end of our stream, and I'll take another picture of Vesta, and I'll see if it moves. I can't remember. There's another object that moves super fast. Oh, it's Flora. Okay, so we're going to go to asteroid Flora real quick while we're on the topic of this. Oh, it's in Taurus. That might be set actually by the time I'm done. So we're just gonna forget about it. Okay, now we can actually look at cool things. I'm so excited now that things are working. Okay, so let's look at the Leo triplets one more time, just because we really couldn't get them that good the first time, that well. So we're gonna go to M66. So let's go. There goes the telescope. It literally moved like 1 inch. Oh, okay. And so here is our galaxy. And so I'll show you what I was trying to do earlier. So I lower the exposure, and then I have my joystick, and I can just move it. Oh my gosh, do you see? I'm gonna cry because it's working. I was so stressed out earlier because it wasn't working. Now it's centered. I can actually like make it even more centered now. Whatever. So, oh my gosh, I'm so happy. And I can make the exposure long. We'll do 12 seconds. And now it's going to be centered and not cut off at the edge of the picture. So yeah, let's see. Thank you for the follow, Johnny Boy. Johnny Boy 9102. Thank you so much for the follow. There is our galaxy, and that looks so much more better. Oh my goodness, look how cool that is. And so again, we're getting a lot of like light noise from the dome lights. So I'll try to get rid of that by making the picture black and white. Cool. Look at our galaxy, our Leo triplet M66. I'm so happy right now. This is so cool. So this is a barred spiral galaxy. So let's talk a little bit about this. This is a live image, by the way. So like all these pictures that we take, they're totally live. Like you see me moving the telescope. So M66 here, barred spiral galaxy. So, oh, there's a cloud. So I have to go to the picture. So we have this like line right here in the galaxy, and then we have these spiral arms. And so we actually, I think there's evidence that shows that the Milky Way, our own galaxy, is a barred spiral galaxy. And I think these are the coolest ones, just because they have like a little bar. And so that really bright spot in the galaxy, that is the nucleus. That's the core of the galaxy. I don't know why I said it like that. That is the galactic core. And that is where the supermassive black hole in the galaxy lives. And that's where a lot of really, really, really old stars orbit. So I think, I forgot what galaxy it was. I think it actually was our own galaxy. I don't know. But how we know that there's these black holes and how we know that there's some, insanely massive object in the center of galaxies is that we took decades worth of data of stars at the center of a galaxy, and I believe it was our own galaxy, where we took, a picture and every 5 years. I mean, there's more pictures than that, but over, a few decades of data, you can actually see these stars slowly orbiting around a center of mass. And, you can't see black holes. They're black. And they blend in with the background of space. So, yeah. And that's how we could tell that there was, some type of object. And plus there's, other math and stuff to support that. So that is super cool. So there's all those old stars orbiting there. And there's not a lot of like gas and dust in the center of galaxies. It's just old material. And where the gas and dust in galaxies lie is in the arms of the galaxy. And that's where all of the like active star forming activity happens, is in the arms of the galaxy. And so that's where we get baby stars. That's where we can get like extra solar systems. And so I hate saying that, extra solar systems, because soul means sun. So we're talking about us, but there's no other sun. We're the only sun. Other stars, the stars are like extrastellar systems. Yes, but that sounds so other solar systems basically that are outside of our galaxy. That's where they form. Other planets, other things like that. Comets, asteroids, stars, nebulas, all that stuff happens in the spiral arms. So this is a really pretty one. So let's go to something else. Let's go to the Hamburger Galaxy NGC 3628. So I moved the telescope, it moved again like 1 inch. Let's see, is there cloud? Like, that looks so cool. Sometimes when I get, these really cool pictures, I just imagine, what Percival Lowell or like B.M. Slifer, when they were here back in their day, taking pictures with the Clark and stuff. I can just imagine like what their feelings were when they saw like all these really cool objects. It's so cool to be able to do this. I love it. So let's crank up our exposure. I just centered our object in, and we should see a really cool spiral galaxy edge on. So I don't know if this one's going to be a barred spiral. I think, no, this one's just a regular spiral galaxy. So regular spirals just don't have a bar in the middle. That kind of looks a little weird. There might be a cloud in the way. So yeah, I think there might actually just be a cloud passing in front of this one. It might get better. Yep. Who was right? I was right. So here is an edge on spiral galaxy. And so how I can tell that, because, to people who don't know a lot about galaxies might be like, what do you mean? How do you know this is edge on? And so just like that last galaxy, I'll pull up the picture of it here. So this one's like this. It's like face on, and we have our bright core nucleus, and then we have the, spiral arms. And in the spiral arms, I was just saying how there's dust and there's gas. And so when we look at that edge on, the gas and dust is really thick. So because it's like face on, we don't see like how thick it is, but it's really thick and it's really dense and it's dark. And so when they're edge on like that, that dense gas and dust is so thick that light isn't, can't go through it. And so we can see a bright kind of central area here, and that's where the nucleus or the core is. And then the spiral arms kind of blocking the light from the core. And so that's how I can know it's like edge on like this. So that's a cool one, but I'm not going to take a picture of that because it's not my favorite. And then let's do the other Leo triplet just because we're there. We'll do M65 Lego. Okay, so let me shorten the exposure so we can center it. There it is. It's a little tiny one, but that's okay. We'll move it so it's in the center. Oh, it's moving so slow. So I'm just doing this really quick. Okay, there we go. Let's go back. Let's do like a 15-second exposure, and let's see how this looks. And so, by the way, now that the telescope is working and now that I can like align things, if you guys have any recommendations, feel free to put them in the chat. Like if you want to see a star, if you want to see something, just let me know in the chat and I'll try to see if that object is up or something like that object is up. I really want to show you guys like everything. everything. So here is M65. This is the other Leo triplet. This one's actually a lot bigger. It looked really tiny, but that's because I had a short exposure. But here it is. It's another spiral, and that one looks really cool. There was a request earlier for M42 and Orion. Oh my goodness. Totally forgot. And you know what? Orion's like really low. So let's get this before it's set. M42. That is the Orion Nebula. All right, so I'm going to move the telescope, and this time it's going to move a lot. So let's go. Let's see. There we go. There she goes. I love watching the telescope move. It is so cool. Oh my gosh, and that looks so bright. So I'm going to just go to a picture, and I'm going to move the dome. This time you actually might see the dome moving, so I'll just leave it pointing at the roof here for a second while I move the telescope down. So give me a second to move it. I'll BRB. And so, yeah, I don't know. It might pass in front of the camera. We'll see if you can see the dome moving here. But, you know, a lot of the constellations that I'm so used to being up, like Orion and Taurus and Pleiades and things like that, they're all setting now. Like they're all so close to the horizon. And it's just so crazy how those are setting. I don't know. It's been a really cloudy winter for us here in Flagstaff. So I didn't get to see the sky as much as I would like to. So it's crazy to see the constellations change so drastically. But now we have Leo, we have Virgo. A lot of the northern constellations are coming back up at the right time. So it's Big Dipper. Okay, we're getting close here. Let's see. Okay, so I'm gonna line my telescope just a little bit. All right, that should be good enough. Let's take a little look and see how it looks. All right, let's go. Oh, that's so cool. Okay, I'm gonna center it. Let's go. Let's go. Oh, and I made it black and white because of that light interference that like from the dome. Might be better though. Let's see it. Let's see it. It looks a little blurry. I'm gonna focus the telescope again, real quick. Now that everything's in working order, I'm kind of up here. So let's see. Oh, that looks so good. Oh my god. Oh my god. Oh my god. Can I get any better? Oh, I made it look so cool. So here is M42, the Orion Nebula. So this is where little baby stars are formed. Let me turn my saturation back up just so we can see the color, but we might, again, get some like light interference from the dome. Oh, we actually don't. Oh my god, that looks so cool. Ah! So you can see some blue and you can see some pink. And so that is the color of the nebula. I'm just trying to like make it nice and pretty here. And so the nebula, it looks like it's moving around, like wobbling. And so that's not actually like the object moving, that's the sky, that's the atmosphere. The atmosphere is moving around. It like wobbles around like water. So if you have ever seen an object at the bottom of a pool and like the water's moving around, the light's being bent, our atmosphere does the same thing. And that's why we send telescopes to outer space to look at things, because in outer space, there's no atmosphere. And we get these really cool, crystal clear pictures of things. Oh, did we get more follows? Thank you so much, Happy Hoovian11 for the follow. But so that's what the atmosphere does. And this is a stellar nursery. So this is where little tiny baby stars are born. And it's this big cloud of gas and dust. And so the different colors represent like the different elements that are in this nebula. The nebula just means gas and dust. So like hydrogen, helium, those are like the building blocks of the universe and our galaxy, hydrogen and helium. So that's going to be really abundant in a lot of these nebulas. A lot of nebulas are mainly consisted of that. And so, yeah. And so this cloud of gas and dust, it's so thick and it's so dense that there's actually portions that collapse upon itself. You know, think of like how, you know, black holes when they form, it's like space-time like collapsing. And so this gas and dust like collapses and starts like nuclear fusion and starts like stellar fusion and like starts making little tiny baby stars. And so over time, these stars, when they're being formed, you know, we have all this energy going on. And so this energy is being expelled and like winds, the stellar winds, the stars make wind, and they blow the gas and dust that they're being formed in, and they blow it out. And so that's why this nebula right here, it's like it kind of looks open because these stars are blowing it open. They have very strong stellar wind. And so while they're doing that, they're like accreting material around it. So they're making little baby extrastellar systems and making little baby planets. And so, oh, we got a cloud passing in front of it. Oh, maybe it was just a little, oh, something's going on. So nebulas is so cool. I think nebulas is so beautiful. But we have another request, NGC 2392. So let me see what I can do here. And so that's what I like about my system is I can just type in NGC 2392 and see what we can get. Oh, clown face. I love this one. It's like straight up too. Hopefully we don't have to move the dome. I'm so cold right now. Okay. Do I have to move the dome? Clown face. Here we go. Oh, this one looks so good through this camera. This one's so awesome. Okay, so I'm gonna jog the telescope. Oh, too much. Okay, so this is another nebula, but it's a different type of nebula. Let me zoom in and like make the exposure a little bit longer. Yeah, the quality is a little poor, and that's just because of the atmosphere and like the conditions tonight. Again, it's like partly cloudy. It's like, you know, doesn't want to work with us. Atmosphere is moving all over the place. This picture looks really still while I say that. It's like strangely still. But so this is the Clown Face Nebula. And so on a better night when it's not crazy, we actually can see like a clown face. So there's like, you know, eyes here, that bright spot in the middle of the nose. You can see a mouth and like all this surrounds like the hair. And so this is a different type of nebula. It's called a planetary nebula. So this one isn't formed from, you know, gas and dust and baby stars. This type of nebula is gas and dust from a dead star. So there was a star that was around the size of our sun. So around the size, maybe a little bit smaller. And when stars the size of our sun die, they don't have a very eventful death. They just kind of, you know, fade out. They just kind of like dim out here. And so my favorite example that I like to use is a bath bomb. So when you put a bath bomb in the water, it kind of like fizzles out and like that, you know, stuff, the soap in the bath bomb kind of like drifts out and makes a circle and you get these pretty colors. The same thing happens when these stars die. So the outer layers of the star kind of like drift off and we get some really cool colors. And the colors, again, represent like the different elements that were in the outer layers of the star. So we get that, and then we get these really pretty planetary nebulas. And so that really bright spot in the center there, that is a white dwarf. So white dwarf is the leftover remnant of these dead tiny stars. And so eventually these white dwarfs will just kind of like cool down and almost become like a rock because they're not, you know, actively making energy anymore. They're just kind of like existing. And so, yeah, over time, they're just going to like stop making energy and just harden up. All that gas will just harden up like a rock and make a brown dwarf. So Sanyam Sharma asks, why is there red light on the dome? That is a great question. So the reason why I have red lights in the telescope dome is because I want to see my surroundings. And so we usually have the lights off in here. And so the lights are off so we can see, you know, the space better, and our eyes can adjust to the night sky. But if I want to see what's around me, I don't want to use like a bright white light. You know, I don't want to use like a flashlight or like some white overhead lights, LED lights. And so we use red lights. And red lights are the easiest light on your eye. And so that's just because red is like the longest visual wavelength. And so again, it's a lot easier on our eyes. So when we look through the telescope, we can still see things, because when we look at short wavelengths like blue light, like how I am with my computer, or like white light, like the phone, it can really damage our night vision, and then we can't see objects really well. So all over campus, we have a whole bunch of red lights, so we can see things still, but it doesn't damage our night vision. So yeah, so let's check. Thank you so much to DJC66 for the follow. And yeah, no problem, John Scary. I'm going to try to get the other one that you asked for too. AbCab says, so pretty. And what's a planetary nebula? I hope I answered your question when it comes to that. So yeah, that's why we have red lights. And yeah, so let's try that other one that John Scary asked for. Or it wasn't John Scary, it's Charlie Allen. Oh my gosh, it's Charlie Allen asked for NGC 2301. So let's see if that one is up in the sky. NGC 2301. Wow, let's see. Oh, it is. It's right below Procyon. Okay, so I'm going to go here. So let's move the telescope. All right, let's see. Thank you so much, JD Scherer, for the follow. I hope you enjoy our stream tonight. If you have any recommendations for any objects, please let me know. Okay, so I'm going to move the telescope dome just a tiny bit. Coincidentally, we're in like that area already. So I'm going to move the dome just really quick. I'll move it just so it's kind of like in the field of view there. Okay, we should be all nice and centered. Let's see. I'm still getting some red light. Maybe I have to move the dome just a little bit more. Okay, no, too much. Oh my goodness. Yeah, too much. Okay, that will be fine for now. Okay, so let's see. So this object, I said it was an open cluster, I'm pretty sure. Let me look, yeah. So this is Haggard's Dragon Cluster. So let me jog the telescope here so we can see if there's more stars kind of around. Oh no. I thought my joystick stopped working for a second. I was about to cry again. Oh my gosh. Oh my gosh. Here we go. Here we go. Wow. So it's Charlie Allen asked for this one, the Haggard's Dragon Cluster. Wow, look at that. So this one's crazy because there's like different colored stars. There's like a red one, there's like yellow, blue. This is a really cool open cluster. So open cluster. So this is a bunch of stars that are clustered together. That's why we call them clusters. And this one's an open cluster. Oh my God, sorry. I'm just like, it's finally like resolving these like little tiny ones too. This is so cool. Sorry about this red too. This is again light from the dome. The open clusters of stars are young stars that are living next to each other. So that object that we just looked at 2 images before, the Orion Nebula M42, that big cloud of gas and dust, this is what happens later on in its life. So when the baby stars are being formed, you know, they're eating up all that gas and dust, they're blowing it away. And then eventually those stars, you know, blow away all the gas and dust around it, or they like eat it up to make extrasolar systems. And then we're left with open clusters of stars. So again, they're younger stars. They're not babies, but they're still pretty young. I would say like, you know, maybe they're like 12 years old if it were to be in a human lifespan. They're fairly young, maybe their teenage years or something like that. So younger stars. So this is a really cool cluster. Let's see. Oh, everyone's being so nice. It's Charlie says, that's so pretty. Thank you. Sakura. Okay. Says hard eyes. Abcab says, looks like glitter. It's Charlie Allen says, would that be considered a double star in the open cluster? And then Abcab asks, what's a double star? So that's a really good question. And thank you so much, Sakura K. Sakura K for the follow. Thank you so much. So I guess, so there's different ways to classify double stars. So a double star or a binary star are two stars that orbit each other. And so it's actually pretty common for stars to have a partner or like a little companion, a little friend that it orbits around each other. And so the sun actually is like a little bit out of the ordinary because it doesn't have a companion. It doesn't have a little partner. And so, yeah, usually stars have at least one other star orbiting around it. And so that's what a binary star is. And then there is different types of double stars. So there's visual double stars, and then there is actual double stars. And so visual double stars is where relative to us, so when I'm standing here on Earth looking up in the sky, it looks like there's two stars orbiting each other, but in reality, those stars are, light years away from each other. They're nowhere close to each other. They just so happen to be next to each other in our field of view. And then true double stars are when there actually is, those two stars are actually orbiting each other. And so it's hard to say with this open cluster if those are actually binary stars or if they're just visual. And I, again, don't know a lot about this open cluster. So it is possible that these are true binary stars. But for me, not knowing anything at all about this cluster, I would say that they're visual just because with open clusters, there's so many stars that, of course, visually they're going to look like they're next to each other, but in reality, they are not. So I would say they're visual, but there is a very, very good chance that they could actually just be true binary stars. All right. So I'm getting close to time here because I'm getting really, really cold, actually. So if anyone has like any other requests of like things that they're like really dying to see, it is so cold. It is like, let me look at the temperature right now. Oh, it's 27 degrees. It's 27 degrees with 80% humidity. Oh my God. So it says it feels like it's 19 degrees. So it's really cold. So yeah, if anyone has any other recommendations, we'd be more than happy to show you some things. If not, I'll end off with like 2 or 3 more objects that I'll show you. Okay, so while I'm waiting to see if you guys put anything in the chat, I'll just go to some objects. So we're kind of in the southern part of the sky right now, and I really don't want to get up and move the telescope too much. So we'll see what else is in this part of the sky. Try to warm up my hands here real quick. Actually, let me see. I want to look at a globular cluster. Oh wait, when did we take that picture of Vesta? I totally forgot. Let's go back to Vesta and see if it moved at all. So I took a picture of the right ascension and declination on my phone at the time that we took that picture. And so the reason why I did that is because we want to go to the exact same spot that it was in before. Because if I were just to point my telescope there, then it would go exactly where the asteroid is, and that's not going to help us. We want to go to the R index. Actually, I don't know. I might just have to align it just like this. Yeah, let's just go to it. We'll see. We'll play around and we'll see what we can do. So let's go back to Vesta. Close hands, close hands. All right, telescope moving. There we go. Nice. Okay, so now I'm going to move the dome here real quick. Watch me go. I'm having so much fun. Even though it's so cold outside, I'm having so much fun. This is my favorite thing to do. Like, I get this telescope and I get to look at cool things and talk to you guys and, you know, share this experience. So I'm having a blast. Okay. Let me see. Almost there. Just a little bit more. And, oh, and I can actually see it because the camera. Okay, a little bit more. How's that looking? Let's see. So what I'm gonna do, where the heck? Where is it? Go back to this stuff. Why don't I see it? Is there a cloud? No, there shouldn't be a cloud. Why can't I see it? Oh, it's because I was zoomed in. Haha. Funny. So I'm going to align the picture. Yeah, it's definitely moved. So let me see here. Okay, so there's these two stars here. Okay, so we're gonna try to get the same exact field of view here. Cool tan. Okay, so two stars, one right here, one right there. Okay, so let's move this bad boy down here. Nope. And so something that I'm going to do when I get home with this picture is I'm going to try to align them perfectly so we can see. What's that? What the heck? Is it by a bright star? It is. That's HD 96372. Which one is best? Now I don't know. Maybe I should just go to the RA index like I planned. Which one is it? There's two of them. Oh, that's not good. Two stars, just like that. Do you see anything like that? Maybe the fun game that we're playing here. Okay, let's pretend it's that one. Just for now, so you can see. Let's go back. Let's go. Oh, it's this one. It has to be. It is so windy. I can hear everything rattling and shaking. All right, two stars. No, that does not help at all. Did it move that much? Oh, maybe these are the two stars. What is going on? I'm confusing everyone right now. Yeah, it might have moved just like too much for me to tell in that hour. Let me go to the RA index like I planned. I don't think that's going to help us at all because I think it moved a lot. So basically what I'm trying to do is I'm trying to align my field of view with the exact field of view that it was earlier, but it seems that it moved way too much to where I'm just gonna have to enter it in. But it's Charlie Allen asks, quick question, but do you think light pollution filters are worth it? You know what, Charlie? I have never heard of a light pollution filter, so that is news to me. And I would definitely say it's worth it because if it filters out light pollution, then yeah, especially if you're from a city, from a big city where there's a lot of light pollution. But if they're really pricey, you know, I have no idea how much these objects or these filters cost. If they're really pricey, it might just be worth it to spend the money on gas and just drive out to a dark place and view the object there and spend a night there. But I guess it's up to you and convenience factor. But yeah, I don't actually know how those things work, and I've never heard of one again. I actually don't have my own personal telescope. I'm really fortunate to be able to use the telescopes here on campus and play around with them. So I don't necessarily need my own. Okay, so we're in the same field of view, and it looks like it did move a lot. Let me bring this up here. This should be the same exact field of view. No, it's not. Oh, two stars. Yeah, I don't know what's going on here. We might just have to call this one, call it, because I'm not getting the same field of view. I thought that would be fun. Maybe I'll try a little bit later. Yeah, I can't tell. We'll look a little bit later. I'll try that one because I am really cold. My hands are freezing. Okay, so let's try one more really cool object and then we'll call it a night unless someone else has a recommendation. Okay, so also another reason why I like Sky Safari is because if I don't know what to look at, I can just pull up tonight's stuff and it'll show me the best objects tonight. And we looked at galaxies, we looked at open clusters, we looked at a nebula, we looked at a planetary nebula. So let me think. Okay, so I'll give you guys an option. Do we want to look at a globular cluster or do we want to look at another galaxy? We can do either of those. So let me know. What do you think? Galaxy, globular cluster. Galaxy, globular cluster. I'll try to maybe squeeze something else in too. There's so many things. I wish it wasn't so cold. So it should be warming up here in Flagstaff. And then when it does, I'll be able to be here all night and look at things. Oh my gosh, I'm totally forgetting the Messier Marathon. If the Messier Marathon happens this weekend, you guys can look at everything. Galaxies, globular clusters, like anything. So, all right, so the consensus, I think, is galaxy. We got galaxy from Charlie, galaxy from Sakura, galaxy from John, and then from YouTube, we got galaxy, we got glob. Okay, so we're gonna go to the galaxy. I'm going to go to the sunflower galaxy. Let's see how this one looks. Let me warm up my hands here. The iPad can't read my hands. Oh, actually, I'm gonna try whirlpool. Let's see how this one is. Okay, let's go. Go to. So I'm gonna move it. So the Messier Marathon, JB asked what it was. So the Messier Marathon is going to be happening this weekend on Saturday. This isn't it. Oh my gosh. It's going to happen this Saturday. I'm going to move the dome here while I talk. And basically, there is this catalog of objects, and it's called the Messier catalog. And so there's like 120 objects or something like that in this catalog of all these really cool things. There's like galaxies and globular clusters and open clusters and planetary nebulas and, you know, just really, really cool things. And so a Messier Marathon is when during nighttime, or, you know, you get like a long period of time where you try to view every single Messier object in the catalog. Something just happened. I think I just like did something to the light. And so that stream is going to be like a 12-hour long stream, and it's going to happen from like 6:45 at night to like 6:45 in the morning. And so it's going to be crazy long, but it's going to be crazy fun. Thank you so much for the follow, Infected Wound. Oh my God. Thank you so much. Okay. So that is what a Messier Marathon is, and it's going to be so much fun. And so you definitely should tune in. We're going to be doing it on Twitch and on YouTube. So whichever platform you prefer, we're going to be doing it on there. And it's going to be super fun. So I'm going to be doing it. I'll be on stream around, I think around 11-ish, midnight-ish. And so tune in at that time if you want to see me. But a lot of the other educators who work here are going to be doing it too. And they're super fun and they're super knowledgeable. So whenever you can, just tune in, and it's going to be such a great time. And so fingers crossed for the weather. We hope that the weather is good here. Sorry, my gamer name is in here. This is Curtis. Oh my God. Curtis is my supervisor. Oh, that is so funny. What's up, Curtis? So here is the last object that we'll look at tonight. Again, just because I am literally frozen solid. My hands, they are in pain. I have these hand warmers, but it's so cold that they're not warm. So this is the Whirlpool Galaxy. This is one of my favorite galaxies. It's actually like 2 in 1. So like, oh my God, Curtis Horn, a viewer from YouTube. Oh, I thought it was Curtis, my supervisor. But the Whirlpool galaxy. So this is actually an interacting, like kind of merging event galaxy. So there's that, tiny galaxy that's passing by this larger galaxy, and it's actually like changing the shape of the galaxies. So this one, if we had a longer exposure, I can actually turn the exposure up here just a second. We can actually see that one of the arms is like straightening out, and it's like being pulled by this little galaxy. Curtis says, "No, I'm the Curtis that was in YouTube. I'm so sorry. I thought it was my manager, Curtis. But Whirlpool Galaxy's lit. Yeah, thank you. Can I stack? I can stack images, but it's really windy right now. It's really windy. The atmosphere is all over the place. So I think if I stack the image, it would just come out looking absolutely awful. So I'm just trying to keep it short and sweet here, short and sweet. We do try to stack images though on good, clear, calm nights. So I think it's one of the first streams that we did. It was a really awesome night, super clear. It was super still, no wind, and we were stacking images, and we got some really crazy pictures. So yeah. JD asks, when will they collide? So I actually don't know. I don't even know if these two will actually collide or if they're just like passing by each other. And if they do collide, it'll be in like billions of years. So not anytime soon. And actually, the Milky Way is in a collision course right now with another galaxy, which is the Andromeda galaxy. So these aren't, rare events, and that's actually how galaxies get bigger, is through colliding and merging and passing by with other galaxies. And so the Milky Way passed by other galaxies and ate them up, and so that's a theory on why we have globular clusters. And then in the future, in a billion years, not anytime soon, the Milky Way and the Andromeda galaxy are going to collide with one another and make the galaxy Milkdromeda. And so that interaction is already happening. So I think it's like the galactic halos from both of the galaxies, or we can see like some evidence that they're like interacting. But again, nothing we'll be able to notice, and nothing that's definitely going to be noticeable in our lifetime. So yeah. Okay, so yeah, I think I'm going to call it, just because it's getting close to 11 here, and yeah, really cold. But thank you guys so much for tuning in tonight. I had such a great time. Be sure to check out the Messier Marathon that we're doing this weekend. I also might be doing a day stream for Twitch this week, possibly on like Friday. So if you aren't followed on Twitch, follow us and you'll get a notification if we do stream here this week. And we're going to be trying to stream more here on Twitch during the day too. So if some of these nighttime streams are a little bit too late for you, we'll be doing some day streams and maybe looking at the sun and some daytime objects, just like stars, just so you can see that we can see things during the day. So let me answer some of these questions. John says, thanks, please go get warm. Yeah, definitely. RW Grim says, is that marathon all weekend or just a specific day? That's a great question. So yeah, it's just going to be one day, but it like happens overnight. So it's like technically 2 days. It happens Saturday night at 6:45 p.m. So let me look at that date again. It's like March 20th. Yeah. So March 20th, 6:45 p.m. overnight until March 21st, 6:45 a.m. And so we have 12 hours to look at all 120 something Messier objects. And then in between kind of like lull times when we've gotten everything in the sky for that time, we'll take requests too. So tune in for that. Subscribe to us on YouTube. Check out our premium access events. And yeah. So thank you all again so much for tuning in. Oh, here, wait, another question. Before we go, which galaxy is this that we're looking at? This is a Whirlpool galaxy. Yeah, this is a really cool galaxy. And so one last thing, we do this every Tuesday. So this is a regularly scheduled event, weather permitting. And so we usually stream first on YouTube, and we do interactive stargazing, where it's more of a quicker, shorter event because we use the open deck observatory, and that's like out in the open. It's like super cold and super frigid, so the educators get really cold really fast, and that's supposed to be more of a faster event. And then this we do right after interactive stargazing at around 9 o'clock on Tuesdays, again, weather permitting. And this is more giving us more time to look at the objects because we're in an enclosed area instead of outside. But it's pretty cold in here, but I don't get hit by all that wind. So, all right. Oh, it's shout out to Bruce Bat Wayne. Thank you so much for the follow, Bruce Bat Wayne. I appreciate it. But again, thank you all so much. And I hope to see you guys here on the weekend and next Tuesday. So bye, everyone. Thank you.